Okay, so you want to, you can go to, let's see, switch. All right, so anyways, for your warm-up, take out your Chromebooks, work on the Delta Math intro to sequences and series. Make sure your cell phone's away, your headphones out of your ears. All right. Also, yeah. Stand up. Go. All right. All right. Am I getting the door for this? All right. Make sure you get your handouts. So, warming up with. With Delta Math sequence series. If you finish those, work on, the best way to learn something is to explain it to someone else. That forces you to rework the information in your head. You know what the edge method is? That edge method? I've seen other versions of it.
Quality content.
What's that?
Yeah, put some more quality content. You have 80 subscribers.
Well,
With 189 videos, you're only a little bit away from your 1 million.
where's that? Like,
Not that far, so it's a simple process.
like, are there any math Yeah. Really? That's all common.
But you have to get a girlfriend and then feature her on your videos.
Yeah.
And that'll bring you some more subscribers. Whoa.
All right, so
Get a girlfriend and then
the world is a.
No. He got hit so hard that he tripped on one of the things on the parking spot, and his head knocked himself out. Funniest thing I've ever seen in my life.
So let's not take pleasure at the pain.
I doubt you felt. Dude, that's like on something.
We should have some passion for these downtrodden.
Wait, so you want us to go to the live stream?
So have that live stream open in a tab. All right, so yeah, so yeah, as I said, so
Don't be on your phone, Trinity.
Yeah. So don't.
When was I saw me on my phone?
Every day of ever existence.
Okay, guys, got it. First installment like next 3 minutes. So. You y'all look good. Make me look good.
If somebody's coming, go. I got you. Let me see that bonus.
All right. So.
Make us seem smart, we should just go over it some
Well, no, this is we're doing. I think today the lesson today is not too challenging. Just make sure you have your writing utensil. Anybody need a writing utensil? Anybody need a writing utensil? Y'all got writing utensils. Y'all got your notes. Okay. All right. After I take a tense, we're just gonna start going through the notes. All right. The people who aren't here are Michael and Levea. Okay. Here we go. All right. All right. So, all right, we're guys ready to start? So, let's look at this first sequence. And so, by the way, a sequence is just all right. Nice. All right. So if you're live stream, go to YouTube. And then is it not there as like a currently streaming? But yeah, that's what it should be called. It I don't know how to change the title. Okay. One second. And it go. All right. All right. I don't know how to change the title. All right, so you guys can access this. What if I switch my account and approve it and then have you guys refresh? All right. All right, approve. I've approved everything. Okay. Now try it one more time. All right, so you guys can access this. What if I switch my account and approve it and have you guys refresh? You guys are in?
Yeah.
All right. All right. So look at keep the volume off just because you're gonna have an echo of what I've been saying for like the past 30 minutes. Or sorry, 30 with a 30-second lag. But now, first of all, we have I'm gonna open this. This will always allow you to go back and go back and look what we have going on. Now, what's looking at each of these lists of numbers that follow a pattern, what would you all say the pattern is for the first sequence of numbers. Yep. So we can say each term increases by 8. All right. Cross, what do you think happens to the second term? What looks like the pattern? Right? So it increases by 8, decreases by 3. All right. Do you have a volunteer for the next one? What do you think is going on here? What pattern are we affecting to go from the first term to the second term to the third term to the fourth term? Okay, so here you want to have a. So here's the deal. We want to have a consistent. We want to have a consistent rule where you apply that rule from one number to the next number and some work. So sometimes it could be addition, but other times it could be multiplication. So what? Negative 4. Negative 1 times negative 4 is. Well, negative 1 times negative 4 is positive 4. Positive 4 times negative 4 is negative 16 times negative 4 is. So if you see a sequence where the numbers are alternating, then if the numbers are alternating, then that's going to be negative 1, positive 4, negative 16, positive 64. Make sure you get your hand out. All right, so for the third term, we multiply by negative 4. All right. 100, 50, 25, 12.5. What's happening here? Yep, divide by 2. All right. Now, want you to pair up, discuss with your partner for about 30 seconds, 45 seconds. Think about what's happening. What was that? Yeah, think about what's happening in this fifth pattern. And you. So I want you to try talking, focusing on this last pattern, thinking about what sort of rule could you come up with that explains what's going on? So this one's a little bit tough. Here's where there's different ways.
We have doing this. We have snap. Just EX.
All right, here. Come on. I need y'all to be on task.
So whatever you add, you just multiply it by 3.
Yeah, so think about it. You might not, it doesn't seem to be a direct pattern at first, because you see, oh, but if you chart out what you're adding for each term, you still might find a pattern. So for example, 1 to 9, you add 8. 9 to 33, you add 24. 33 to 105, you add 72. But 8 times 1 is 8, obviously. 8 times 3 is 24. 24 times 3 is 72. So how could we describe what's happening in words?
It's I don't know how you put that. Yeah.
Because you think about it.
No, I know it's happening, but I don't know how you actually.
That's the thing. I want you to think about how would you describe what's going on in another person.
So would it be X plus Y times 3?
So think about it this way. For the first term, because the first term, right, you add plus 8, right? Second term plus 8 times 3, right? To get to the first or the second term, you add 8. From the second term to the third term, you add 8 times 3. From the third term to the fourth term, you add 8 times 3 times 3. So think about it. Get to the term that you add from the first to the second is 8 times 3 to the 0. The term that you add to go from the second to the third is 8 times 3 to the 1. The term that you add to get to the third, from the second to the third, or sorry, from the third to the fourth is 8 times 3 squared. So you can say add 8 times 3 raised to the for example, the term number minus 1. Because if you are going from the first term to the second term, that's 8. That's 8 times 3 to the term number is 0. So the term number minus 1. You go from the first term, 1 minus 0 minus 1 is 0. 8 times 3 to the 0 is 8 times 1. So the term number minus 1. So, for example, you're at the first term. 1 minus 1 is 0. That's 8 times 3 to the 0. 3 to the 0 is 1. 8 times 1 is 8, so you add 8. Second to the third term, the term number you're starting at is 2. 2 minus 1 is 1. 8 times 3 to the first power. 3 3 to the first power is 3. 8 times 3 is 24. So add 8 times 3 to the term number minus 1. So start thinking about these patterns. All right. Any questions at all? Okay. We're going to go to the next slide. All right. So we think about notation. N is the number term in the sequence, and the output and the term outputs a value an. So for example, a1. So I'm just going to cold call because this is kind of in the graph. Kevin, what's a1? So for example 1, what's a1? The first term. Yeah, there we go. So just Dante a2, Austin a3. Yep. And then Maya a6. So here, so this one takes a little bit extra work because the first term, the second term, the third term, the fourth term, the fifth term, we find the pattern first. So now we have to find what's worked together and find the pattern and figure out what we're doing each time. So first, from 4 to 6, how do we get from 4 to 6? So it looks like we could add 2. Yes. Yeah. So think about, yeah. So yeah, because think about it. 4, half of 4 is 2. 2 plus 4 is 6. Half of 6 is 3. 3 plus 6 is 9. Half of 9 is 4.5. 4.5 plus 9 is 13.5. Half of 13.5 is 6.25. 13.5 plus 6.25. Sorry, 6.75. 6.75 plus 13.5 is 20.25. Half of 20 point. What's half of 20.25? Yeah, so that's going to be plus 10.125. Yep. So that's going to be equal to 30.375. All right, Michael, make sure you grab your guide notes. And make sure you grab a pencil and make sure you diligently take notes. All right. All right. Now, this is one thing where you need to understand this pattern recognition by it's less of a process. I mean, you can guess and check, but like there's less of a way unless you very easily find a pattern where you're adding or multiplying for your pattern. Sometimes you just gotta see it. And I know that's not helpful as far as giving guys instructions. But if you've exhausted adding or subtracting, sometimes you just need to try certain things out and see how they relate to each other. Okay. So example 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. So we need to find 12. What's the first term, Alicia? 0. Second term for it, or sorry, seventh term. 8. Okay. Fifth term, Corollas. 3. And then now we need to find the 12th term. All right, so identify the pattern. What's going on? All right, so Alex went last time. Someone that's not Alex, try to identify what pattern is going on here. Yeah, so you always add the previous two numbers to make the first number. So 0 plus 1 is 1. Then 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 8 is 13. 8 plus 13 is 21. 21 plus 34 is 55. What's 55 plus 34? 89. So once again, not a standard thing that you're adding or multiplying, but this will test your pattern recognition. Have you guys seen the sequence before? You guys know it's called? Okay, it's called the Fibonacci sequence. All right, so here. Michael, do you need a pencil? Okay. All right. Now, example 3, we have 1, 4, 9, 16, 25, and 36. All right, what's first term out? 1. Seventh term will. Good. All right, now 11th term and 100th term. Think about it. This is where finding the pattern means we don't always count that. Okay. So the first term is 1 squared. The second term is 2 squared. The third term is 3 squared. We could actually probably write a formula that our term number, or the number of the sequence, an, is related to the term number, and an is equal to n squared. So what the term is in the sequence is equal to the term number, whatever that term number is, squared. Third term of the sequence, 3 squared. Fifth term of the sequence, 5 squared. So the 11th term in the sequence is going to be 11 squared, 121. And what about the 100th term? We just do 100 squared, so that's 10,000. How are you guys feeling so far?
I ain't getting that one.
Okay, so I'll have to just walk you guys through examples, but there are ways. There's a limited number of common patterns that you can see. So in preparing for practice questions, I can, show you a bunch of common patterns, and if you've seen and practiced with all of them, it's gonna be fine because you'll be fine because, for example, it's obviously common rules like adding a number, multiplying a number, or the term number squared. Those are common ones that are easy to work with. But if you know what you're looking for, I'm going to give you examples to know what you're looking for. I'm going to make sure you're not stumped on the NCFP. Okay. Recursively defined sequences. Is this sequence defined using what? One or more previous terms which are given. To do so, you have to state the first term and then write the pattern. So let's look at 3, 7, 11, 15. What are we doing each time? We add 4, right? So the pattern words, this time we're going to include, where do we start at? Right, so we start at 3, then we add 4. Okay. Recursive form. First, we indicate what our first term is. So we say A1. This tells me the first term in the sequence is equal to 3. Now we have a comma, and then now we make a statement about any term in the sequence. Because after, we only have a first term in the sequence, but after the first term, we can just indicate any term in the sequence as an is equal to a n minus 1 plus 4. Let's think about what this means. This is all about notation. This is saying any term is equal to the term right before it, n minus 1, plus our pattern. So an is equal to an minus 1 plus 4. All right, so Toby, what would you do for a pattern word for example with 10, 20, 40, 80? Yes, that's absolutely correct. But and then one last thing we have to indicate, what word we start at. Yep, so start at 10. All right, multiply by 2. All right, recursive form. All right, A1 equals 10. All right, Enrique, what would you do for the next part? What would we write for the next part? Use the previous example to help you. Yep, an is equal to. And how do we indicate the previous term? Yep, n minus 1. So any term is equal to the term right before it times 2. Nice job. Okay. Well, before we move on, you'll have any questions. So I think the math behind this is not challenging, but one thing that trips people up is this notation. Okay, example. We have 3, -9, 27, -54. All right. So you all want here, you guys feel comfortable trying a few of these on your own? And then, all right. I'm going to be working throughout them with you. Always say when you start. Start at 3. All right, Michael. Fix yourself up tonight. Yeah. Yeah. Okay. an is equal to an minus 1 plus an minus 2. Guys, come on.
I see that.
Excuse you.
Guys, come on.
Oh my god, writing this is so much. Writing this notation. I have to say, that's probably me. Yeah.
All right, let's bring it in. All right, so looking at the first one, I'm going to point out some things about the pattern, and then we're going to talk about or the example, and then we're going to try to write the pattern. So the first term is 3. The second term is 3 times 3, but it's negative now, 9. The third term is 3 times 9, so the term that we're multiplying by has multiplied by 3. The third, and then the fourth term is 3 times, so, and then after that, that's 3 times 18. So, let's look at our pattern. First we just have 3, but then we can look at this as negative 3 times 3. We have negative 3 times 3 times 3. digits. 3, 2, let's do 3 times negative 3. This is 3. This is 9. Then we have 27. This is 3 times negative 3 times negative 3. Negative 20. And then 54 is going to be negative 54. 3 times is going to be 3 times 18. So 3 times negative 3 times 6.
You know the first one still?
So I'm trying to point out some different patterns and show a different way of looking at it. So see if anyone was able to come up with a recursive form. Okay.
So the first 3 is multiplied by negative 3. And you said it's multiplied by negative 18?
Well, because think about it. 3 times negative 18. Wait, sorry. 3 times negative 18, that's negative 54. So this is 3 times 1, 3 times negative 3, 3 times negative 3, 3 times 9, 3 times negative 18. What we're trying to find out what's the pattern that's going on here. Multiply by 1, then 3, then 9. Right? This might be on the here. This one. This one's using some advanced math, so we'll come back to it later. We add here. Add. This one's much more simple. We just add 4. So the pattern is we start at negative 3. Then we add 4. All right. So your recursive form, A1 is negative 3. AN is equal to AN minus 1 plus 4. Here, this is the Fibonacci sequence, so each term is the sum of the previous term, previous 2. Each term is the sum of previous 2. Was that? Yes, you may. So the recursive form would be A1 is equal to 0. You will also have to say in your recursive form, because you need to, the pattern requires 2 previous terms, you're also going to have to state that A2 is equal to 1 And then you can say for an, the an is equal to an minus 1 plus an minus 2. Yeah, because you have to indicate the first and the second term, and then indicate that each term is the sum of the previous two.
So when you're going from 0 to 1, from A1 to A2, you're not adding two previous numbers, you're only adding one.
Yeah, so like for
When you're writing it in words.
well, so the way that we're looking at least for recursively, you just have to know that your term number is given, right? So 0 and 1 are given. And then once these are just, we have to accept these as they're given as they are, and then we're given a pattern and we have to go with it. All right.
Can I go to reference
Yes. All right. Find the first 5 terms of each sequence. Okay. So a1 is equal to -3. an is equal to 2 times an minus 1 plus 4. a1 is equal to 2. an is equal to an minus 1 minus 3. So what's first term here? It's -3. All right. Then what's the second term? It's 2 times the previous term plus 4. So it's 2 times the previous term plus 4, -2. All right, keep on going with the pattern. 2 times the previous term. Right, well, 2 times the previous term is -4. Right, 2 times -2 is -4. Plus 4 is 0. All right, what's it? Walk me through the next term completely step by step. How will we do it?
2 times 0.
Is
0.
plus is last one.
4 times 2.
Is
8.
plus
4.
is.
12.
All right. Next one. 2. Make sure that your pencil is in your hand and you are following along. All right. First term is, then each term is the previous term minus 3. So the second term is, the next term is, the term after that, term after that. Excellent. Now, here the first term is 128. What are we doing for each consecutive term? Negative 0.5. So what's the next term? All right. And then what's the next one? Positive 32. Next one? Negative 16. Next one? Positive 8. All right. All right. This one, A1 is 1, A2 is 2. So we have 1 and 2 are given. And then each term is the term before it times the term before that term. So what would be term 3 here? Yeah, 1 times 2 is 2. Then term 4, 4. And then term 5, 8. And then term 6 would be 8 times 4 is 32. But now we're going beyond the first 5 terms. All right. Now we're looking at explicit sequences. Now the sequence is defined using n. So now we have to create equations where you plug in the term number, okay, and you get out the form. So the pattern in words is we add 3 to 5, that's you add 2. 5 to 7, you add 2. So you add 2, right? But for the first term in the sequence, that's n is 1. How can we write a formula where n is 1, an is 3? N is 2, the second term in the sequence, an is 5. N is 3, an is 7. Write a formula where the input is n, output is an. So we need a formula where the input is 1 and the output is 3. The input is 2 and the output is 5. So think about if we wanted to plot this, right, remember? We could have an xy axis where our input is our n value and our output is our an value. If our input is 1, the output is 3. If the input is 2, the output is 5. If the input is 3, the output is 7. What type of equation is this? All right, come on, let's sit up straight here. What was that? All right, Kyle. All right, here's the deal. We have our inputs, right? Inputs. 1, 2, 3, and outputs 3, 5, 7. If you had, what type of shape does it make when you plot these inputs? 1, 2, 3, 3, 5, 7. What type of shape is this looking like? Come on, what shape is this? It's a line. Yeah, okay. So this is a line. How would we find the equation of this line? If we had inputs of 1, 3, 2, 5, 3, 7. What's the rate of change? Yeah. So how do we write an equation for a line with a rate of change or slope of 2? Yeah, so y equals mx plus b, okay? What's our rate of change here? 2. So y is equal to 2x. How do we find our y-intercept? Yeah, well, so we want to have a y-intercept where technically our n value is 0. Even though our first term, yeah, so if n is 3, or sorry, if a n is 3 when n is 1, you just subtract 2, right, and you just continue with the pattern of the graph. If your input was theoretically 0, right, add 2, you could also subtract 2 going backwards, the output would be 1. So our y-intercept is 2x is 0, 1. So our explicit form is an is equal to 2n plus 1. You need to be able to plug in your term number, okay, and have it spit out what the term is. So let's look at the pattern words here. 2 to 5, 5 to 10, 10 to 17. So think about it for about 30 seconds and then see if you can come up with a pattern. So I'll help you guys out a little bit here. You add 3, then 5, then 7. But even though you add 3, then 5, then 7, it looks like you're adding a different number. But notice the number that you're adding increases by 2 each time. How could we input our term number and output?
Wow.
Yes.
I'll do it again.
What was that?
I'll do it again.
Okay. Sorry. One, 2, 2, 5, 3, 10. 4, 17. What shape does this is kind of starting to look like. Yeah, it's looking kind of like parabolic. So let's see if that's a hint that we can go to for making something work here. So you're trying to come up with a formula. For a formula, think about how you could do a parabola. All right. Kevin, let's sit up straight. All right, pattern in words. All right. So n is 1, 2, 2, 5, 3, 10, 4, 17. I will work this out. All right. Here's what we do. So here's, hopefully you've kind of found this out. What are we doing to our term number? What do you do first?
Well, you start off 3, but you're adding 2.
Yeah, but as far as actually coming up with a rule that we can write, try looking at what's going on here. Because for each term number, what do we do first? Well, these are term numbers. The first term, the second term, the third term, the fourth term. What's the 1 squared? 1. Right? So the first term squared is 1 plus 1 is 2. The second term, 2 squared is 4 plus 1 is 5. The third term, 3 squared is 9 plus 1 is 10. The fourth term, 4 squared plus 1, or plus squared is 16 plus 1 is 17. So first we square each term. So we square n, then add 1. So an is equal to n squared plus 1. So do you notice how the term that we add is not constant, but the rate of change in what we're adding is? That's a hint that you're raising to the second factor. If so, this is called a first order change. It's called a second order change. First order change, first power, linear. Second order change, second power, quadratic. Third order change, third power, cubic. So that's a hint to what your exponent will look like. But one thing to consider is one pattern you can do is just like know that this is a common pattern to look for, and know your common perfect squares. So if you know 1 squared, 2 squared, 3 squared, 4 squared, 1 cubed, 2 cubed, 3 cubed, 4 cubed, it's going to help you find these explicit forms. Okay. Okay. 2 more slides, and then I'll give you guys some practice. All right, pattern words. 7, 10, 13, 16. So here we 1, 7, 2, 10. All right. 3, 13, and 4, 16. Okay. So, Enrique, what's your pattern in words here? Add 3. Okay. Will, let's start with the recursive form. What's the first term?
A1.
A1. What does A1 equal? Okay. And comma. Yeah, what's AN going to be equal to? AN minus 1, good. But then what do we do to the previous term? Add 3. AN minus 1 plus 3. So it's all about notation. Furthest. Let's think about how we would express this in explicit form. And if it helps, look at these as coordinate points. Okay. So AN. Yeah, all right. Well, yeah. 3N. Okay. Plus 4. All right. So let's think about this. That's 3N plus 4 because 3 is a rate of change. We add 3 each time. Rate of change is slope. And then to find the y-intercept, if our n value is 1, what do you do? What do you do to find the y-intercept? You just looked at. Right. So if we are adding 3 as n increases, for a linear function, you subtract 3 as n decreases. And so 7 minus 3 is 4. If n is 0, then you just subtract 3 on each side. So, what can you notice about the pattern, for example, 2? You don't need to find it. Just anything that you notice about it. Here, you know what? I think when I created this last night, I made a typo that negative h really should be a negative 4. Yeah. So sorry for throwing you guys off. Sorry. Made this last night. But if that's a negative 4, now Toby, what's a pattern that you can see for this example? Wait till we're done with the notes. What's one thing you notice between negative 4, negative 2, negative 1, and negative 0.5? Come on, you want to help her out? Yeah. Well, how do you get from negative 4 to negative 2? Multiply by what would you multiply by? Well, negative 4 times 2 is negative 8. Why? So because negative 2 is 1/2 of negative 4. All right. So Carolus, what's 1/2 of negative 2? 1/2 of negative 2. Negative 1. Toby, what's 1/2 of negative 1? Negative 0.5. That's right. So Kevin, what would you write for your pattern in words? Yeah, I mean, but what would you if you were to describe it, the pattern in words? Yeah, you just divide by 2. All right. Dante, what do you write for your first? Yep. Yeah. That's going to be a n minus 1 over 2. Okay. All right. That was break slope for the explicit form. All right. Well, okay. What about you, Al? Yeah. Okay. Here, let's write out. If n is 1, a n is negative 4. If n is 2, so now we're multiplying by a certain number, right?
So would it be, wait, would it be -8?
Well, so let's write inputs and outputs. You can pull up Desmos and actually plot those inputs and outputs. So we have 1, -4, 2, -2, 3, -1, 4, -0.5. Right? So let's see if we can find a shape here. 1, -4. 2, -2. 3, -1. 4, -0.5. What is this shape looking like again? Oh, all right. Yeah, it's looking parabolic. Okay. So, but now it's a downward facing parabola. So here, work together for about a minute. Minute 30. This takes some exploration. Work on trying to find the equation of this downward facing parabola. These are the coordinate points of a downward facing parabola. Let's see if we can find some information about it. You can also look at this exponentially. The parabolic shape is going to level off and it's going to turn exponential. That's your next hint. Do we alter this -4 at all, or just start from
No, it doesn't. That's why I said, I said AN equals -8 n divided by 2. That's how you get the first time.
Well, but we want to have a rule that's consistent all the way throughout. I know we're kind of exploring and discovering some new math here. But what's anything raised to the 0 power? 1. So what's negative 4 times 1? Right? So anything raised to the 0 power is 1. Negative 4 times 1 is just negative 4. This is going to be negative 4 times 1 half to the 0. In each term, we multiply by 1 half, divide by 2. So what's negative 4 times 1 half to the first power? What's 1 half to the first power? 1 half, right? 1 half times negative 4. Negative 2. What's 1 half squared? 1 half times 1 half is 1 fourth. 1 fourth times negative 4? Negative 1. 1 half cubed. 1 half times 1 half is 1 fourth times 1 half is what's negative 4 times 1 eighth? Negative 0.5 or negative 4 times 1 eighth is also negative 1 half. So we could say this is our first term multiplied by what we multiply our rate of change for each term. All right, but now this is gonna our term number is 1, and then we raise it to the 0 power. Our term number is 2, but we raise it to the first power. Our term number is 3, I raise it to the second power. The term number is 4, I raise it to the third power. So what's how can we get this in terms of a n? So notice that my term number was 1 more than the exponent. So first of all, what's our starting number here? It's negative 4. What's my rate of change? Or my multiply rate? 1 half. Okay? And what power do I raise that 1 half to? Relative to n. Yeah, n comes right. That's n to the n minus 1 power. All right? If it's the first term, that's 1 minus 1 to the 0 power. Second term, 2 minus 1 to the first power. Third term, 3 minus 1 to the second power. So the example is 3, 5, 7, 9. All right, this one's easy. So Trinity said our pattern is we add 2. Michael, help me plot points. For our first term, what's an? So for our first term, what's the term number? You can. All right. So look at the sheet of paper that follows along. Our first. So what's the first term in example 3, 5, 7? A little louder. Yes, like what's the number of the first term? Yeah, just 3. First term is 3. Then your second term is yep. So 2, 5, 3, 3, 7. What's the fourth term? 9. Right. Now. Toby, let's help me out with the recursive. Yeah. You have 8n. Well, first of all, a1 is 3. So I'm giving you guys the first term. An is equal to an minus 1. So, or what's and then Look at it. First of all, what does it start out with notation? What does it start out with notation?
A-N.
A-N. And what's, okay. Now, A-N is going to be equal to, we're going to have to find a rule where N is our input and A-N is our output. What's our rate of change? Adding 2. How would we express this as a line? So if I'm adding by 2 each time, all right. So, yeah. So, Trinity, you are right. Let's break this down why it's the case. If I'm adding by 2 each time, 2 multiplied by my term number. That's what's going on here. So multiply 2 by my term number. And that gives me my rate of change. But now I need to find the y-intercept. How would I find my y-intercept? What's the n value of the y-intercept? On a linear equation, what's the x value of the y-intercept? 0, right? So because it's the input, at the y-intercept, your input value is 0. So there, what would my a-n value be if my n value is 0? Notice I'm adding 2 going forward. What would happen as I move backwards? Subtract 2. So what would be my a-n value be if n was theoretically 0? If I'm subtracting 2. Right, 3 minus 2 is 1. So the y-intercept, y equals mx plus b, a n is equal to 2n plus 1. Test it out to see if it works. If n is 1, 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. 2 times 4 is 8 plus 1 is 9. We're trying to find patterns that work.
Okay, so now I have a question.
Yeah.
So like for that one, you put 2 and plus 1 so you can get the first term, which is 3.
Right.
But then for the one above that, why wouldn't you do negative 8 times 1 half
Okay.
to get the first term of negative 4?
Because here's what you gotta start thinking about. If your pattern is adding, you want to start thinking about the linear function. Because you are adding, think about each term, you're adding to a constant number. So your slope is going to be constant. You increase steadily. But if your term is multiplying, that's going to be an exponential function. Because there's a constant term that you're multiplying by. 2 times 2 times 2 times 2 times 2 times 2 times 2 if you're done. So if your first term is 2, right? And so then it's 2 to the 1. Your second term, we multiply by 2 each time. 2 to the 2. Third term, 2 to the 2 to the 2, or 2 cubed. 2 to the 4th, 2 to the 5th, 2 to the 6th. And so now, if you add, it's linear. But if you multiply, it's exponential. And think about the pattern that we did all the way back in Unit 1. Right? Come on, Kevin. Sit up straight. That's all right. So we're going to find the 5th, 6th, and 10th term of each term. All right. So a(n) equals x squared plus 8. This is the last one. So you guys all a little bit less guidance here. But what's your thought process for how you go about this? Given this is an explicit form.
Getting either 5, 6, and 10 for n.
Yeah. So everybody listen to Curtis. Curtis, say that louder for the group.
Plug in either 5, 6, or 7 into n.
Right. Yeah. So we want to find a fifth term, we just plug in a and is 5. That's 10 squared plus 8. So what's 5 squared? Plus 8, 33. 6 squared.
36.
36 plus 8. Alright, 8, 10. Sorry, 10 squared. Plus 8. Yep. Alright. Now, we'll have, and this is just plugging in. So just, I want you to, the math you've already done before, the notation, so you got to use it. This would be 5 minus 5 times 5 plus 2. 6 minus 5 times 6 plus 2. The hard part is 7 is setting up. 10 minus 5 times 10 plus 2. Plug in 5. 3 times 5 minus 8. 3 times 6 minus 8. 3 times 10. Yeah. Wait, it's not my bad. 3 times, geez, so wait. 3 times 6 is 13 minus 8 is 10. Okay. 3 times 10 is 30. Minus 8 is 22. All right, so your exit data for the day is to finish up your delta math on introduction to sequences and series. That's going to give me data, so work on that. I mean, you have 5 minutes of class, but do try 1 to 2 problems, okay? Finish that up for homework it's due by the beginning by tomorrow. And that's gonna all gonna be able to look at your performance on that and see how well you do. So you can pull up delta map and be going. All right.
Yeah, this is patterns. It's like we live in the answers. No, but this is not this one here. This is one here. It's easy. Yeah, that's weird. But I have both.
Ending the live stream. Stop stream.